Here we have a sample problem that says the Alberta greater sage grouse population was 4,375 in 1970. By 2002, it was only 350 birds. Assuming the population decreased at a constant rate, calculate the growth rate and per capita growth rate during this time. So, in this question, obviously, this population got decimated, quite literally, actually. So, the population has decreased, but we're still talking about growth rate. It's just the growth rate in this case is going to be negative because it got much, much, much smaller. So we started with 4,375 birds. Now we only have 350. So our N, which is going to be our initial population size, is going to be 4,375. Delta N is going to be equal to the new population size minus the original, which is going to be equal to negative 4,025. For our growth rate is equal to the change in population over the change in time. We started this in 1970. We ended it in 2002. So our delta T is going to be 32 years. Our population change is negative 4,025 birds. So this particular population lost 126 birds approximately per year. Again, assuming that this is a constant rate. In reality, it likely would not have been, but on average, we can say the loss is about 126 per year. Then for per capita growth rate, it's going to be the change in birds over the original population. So this is still going to be an average, and it's still going to apply to that 32-year time span, but it's not measured per year. Instead, this time, it will be negative 4,025 birds over our initial 4,375. And that will give us a per capita growth rate of negative 92 hundredths. So for every individual that was in that population, you lost 92% of a bird over that 32-year period. And that does make sense because this population almost got entirely wiped out during that time period. So that per capita growth rate is pretty darn close to -1.